Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Hanani, and I will proceed this presentation with the introduction. So LiDAR is stand for Light Detection and Ranging, is a remote sensing technology. To take the measurement, we can use this technique by using the automated sensor and also can be used to map a region structure as well as plan height, density, and other properties. Another term for LiDAR is active laser scanning.
Assalamualaikum and hi, my name is Alia. I will continue this presentation. We explain about the operating or working system of LiDAR. In typical LiDAR sensor, the surroundings are filled with pulse-like pulse. These pulse return to the sensor after bouncing off nearby object. Based on the animation example shown, we can see the movement of sensor. The sensor determines the distance travelled by each pulse by measuring the time it takes for it to return to the sensor. An accurate real-time 3D map of the environment is proceeded by repeating this procedure millions of times per second. A point cloud is the name given to this is 3D map. The LiDAR point cloud may be used by a on-board computer for secure navigation. Okay, now let's proceed with the video. This video will show you more about how LiDAR works.
You can see here, the single light photon is emitted from the sensor, hits an object like a tree, and bounces back to the LiDAR sensor, at which point the data from the light photon's travels is recorded. It is measuring distance and time. The amazing thing about this is that it works for non-stationary objects in real time, such as pedestrians, bicyclists, and other cars. Because LiDAR is its own light source, it can even see at night. This is an advantage over cameras, which have trouble in darkness. A good LiDAR has from 8 to 128 laser beams to measure the environment. The laser beams in the LiDAR emit billions of light photons per second at 360 degrees in order to completely see the surrounding world. It is pretty amazing that billions of data points and calculations are happening in real time. This allows the car to see and keep drivers, occupants, and all other road users safe. It is kind of like spraying paint all over the surrounding environment in order to highlight objects, make them recognizable, and show movement.
In conclusion, it produces a laser pulse train that is transmitted to the surface or target in order to measure how long it takes for the laser to return to its source. So, the method used to compute the actual distance a returning light photon has traveled to and from an object is calculated by a formula: speed of light multiplied with time of light and divided by 2.
The significant advantage of the laser is it is higher accuracy. For example, the laser can detect objects with vertical dimension 5 until 15 cm and horizontal dimension 13 until 15 cm. Furthermore, the laser can be used for forest structural modeling and surveying, and the multiple outputs of the computation not only can be used with surface or ground level, but also for the intermediate level. When compared to radar technology, radar has far faster acquisition and processing time. This technology can collect, process, and transmit the data to the control center as quickly as possible. When it comes to military equipment or aviation business, where its time is of the essence, quick acquisition and processing times are critical. LiDAR is literally a game changer to this industry. Radar laser require a little human intervention, unlike photogrammetry, GPS, or land surveying, because most of the procedures are automated. That is, it requires a little workforce and can even function without it. This will eventually enable its deployment in locations like North Pole or South Pole, because humans cannot reside permanently owing to harsh weather conditions. This ladder can function effectively even with only a little human assistance. Even under poor weather or lighting, LiDAR technologies can provide precise 3D mapping. This technology can integrate with other on-the-ground technologies to create comprehensive mapping system capable of providing relevant analysis. It's not only provide precise data about static object, but it also provide accurate data about moving objects, such as in automobiles in poor weather or condition. This is especially impressive when it comes to autonomous vehicles. Capacity to collect surface elevation data to the dense foliage such as forest canopy. This multiple laser pulse emitted by LiDAR laser can detect gaps between leaf and branch, just as sunlight filter through the forest canopy and continue down to the ground. Higher canopy penetration will eventually provide various benefits such as detecting illegal drug farms and conducting military operation in dense forests. LiDAR laser can be used during the day or night because it is a lighting emitting method and is not rely on ambient light source, same as photogrammetry case. Given the speed and large area that can be scanned coupled with highly accurate result, LiDAR is significantly less expensive than other methods of land surveying and mapping. It is an affordable way to produce complex topographical surveys. The sensor sends out the laser pulse and receives back in nanoseconds that make it possible to scan large area in fairly short period of time and still get a high volume of data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ruhi Atira Bintikar Aliman. Now I will present about the disadvantage of LiDAR. First of all, LiDAR has a high number of datasets that are challenging to interpret because it is a technology that generates extremely massive datasets that are challenging to analyze and demand a high level of analysis, the volume of data, as well as the computational and technical requirements to process, organize, and store the point cloud can be a significant barrier. Hence, it needs sophisticated data because high performance spatial indexing is required for speedy data access and analysis of LiDAR data. Due to its complexity, processing the data and spotting inconsistencies or error demands a thorough understanding of the technology. Studies frequently produce their final products using only a small subset of the data. Okay, next. LiDAR data is typically not colorized, making it difficult to comprehend without the use of RGB photographs. LiDAR data is difficult to interpret without the use of RGB photographs because it contains so little detail. LiDAR has difficulties in bad weather conditions. This is because LiDAR uses visible lasers in order to measure distance, which makes it difficult to work in dynamic environment. Weather-related scattering and attenuation such as sound reflection, dust, rain, snow, fog, and clouds can alter the quality of data gathered by LiDAR sensor. Okay, next. Low operating altitude of 500 to 2000 meters. The capacity of airborne LiDAR to detect small features is determined by the altitude, direction, and quality. Target items on any platform may be covered by other things in the foreground. Spoof signals can cause problems for users by generating false information which may result in the creation of non-existent objects. And lastly, LiDAR has high running costs in some applications of both initial and ongoing costs. This is because LiDAR involves moving parts which is more prone to failure and thus more expensive to maintain. In car manufacturing, Tesla uses a combination of cameras, radar, and ultrasonic sensors instead.
Assalamualaikum, my name is Nur Najia binti Nur Zailani and I will talk about the future use of LiDAR. So LiDAR is a typical technology for calculating the accurate position of an element on the Earth's surface. LiDAR application in the future will include those in automotive, robotics, smart city infrastructure, and any other industry that now use camera and radar. LiDAR features are used in a variety of land planning and management tasks as well as risk assessments.
Because of its versatility and high resolution, it has application in a wide range of industries, including archaeology, climate monitoring, city planning, meteorology mining, and many others. Future use of LiDAR in robots. LiDAR, which is increasingly becoming a cheap replacement to the IR and ultrasonic range sensors widely used on hobby robots, is now replacing them. Sophisticated software, known as SLAM, is often required to make the most of LiDAR's point cloud data. The algorithm may construct a map of the robot's surroundings by merging scans collected when the robot goes around. Future use of LiDAR in autonomous vehicles. Self-driving cars are expected to hit the market soon and profoundly alter the automotive sector because it scans its environment, estimates distance, detects impediments in its path, fires a laser at them to enlighten them, and then creates a high-resolution digital image. LiDAR may be thought of as an independent vehicle's eye.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adana Sofia binti Ahmad Noor. Another future use of LiDAR is in agriculture. LiDAR helps to use land more efficiently by detail monitoring to boost yield. A LiDAR sensor will be attached to the drone to scan crop for weeds, disperse the fertilizer and seeds. Furthermore, this feature is useful to obtain an accurate maps of the agriculture area and helps locate all the trees in an orchard. Next, LiDAR is useful to determine the surface elevation in forests by precisely striking the item with laser pulse. That helps to figure out the height, width and diameter of each tree. LiDAR also can estimate plot level data such as canopy value, mean, minimum and maximum height, and estimation of the vegetation cover.
In conclusion, LiDAR has enhanced the accuracy of sensing compared to the remote sensing technologies like radar and sonar. Next, to observe the atmospheric backscattering as a function of range, LiDAR uses laser energy in a similar way to radar, and it may map aspects of an object or environment into a point cloud that looks on screen as solid physical objects due to its laser precision. Last but not least, LiDAR is a globally recognized technology that has been proven to be an effective means for gathering incredibly dense and elevation data from landscapes. Compared to radar technology, LiDAR can provide a higher degree of precision and more in-depth knowledge about the landscape. I think that's all from us. Thank you.